Welcome back, everyone. Today, we're putting on our detective hats for this explainer because, well, we're diving into a truly fascinating tech mystery. We're going to unpack this incredibly intriguing GitHub issue report filed by a user going by the handle #AGreenhandJack. It's a classic pull-your-hair-out kind of tale, full of developer frustration, conflicting systems, and those invisible cloud mechanics that I think pretty much anyone working with modern software is going to immediately relate to.
So, here's the central paradox we're going to unravel today. The absolute key word here is identical. We're not talking about some sketchy port or an older version that's lagging behind on one OS. We are talking about the exact same code, the exact same version, and the exact same user account. On a Mac? Smooth sailing. On Linux? Boom. A complete, instant brick wall. I mean, how does that even happen?
All right, Section 1, the cross-platform mystery. To establish our baseline, we've got to look at the setup, version 0.144.0. This right here is the absolute heart of the dispute. It's the version number for the Codex command line interface, the CLI, that our user installed. And I want to boldly highlight this because it's literally the control variable in our little experiment here. The user meticulously ensured this exact specific version was locked in on both of their machines. Think of these two systems running side by side. You've got an Ubuntu 24.04 LTS box and a macOS 15 machine. The user is just trying to access the brand new GPT-5.6 models, specifically variants like Sol, Terra, and Luna. They're using the exact same OpenAI account on both computers. They're using the exact same ChatGPT authentication. The playing field is, for all intents and purposes, entirely level. Which brings us to Section 2, expected versus actual behavior. Let's step into the crime scene and see what happens when these models actually launch. On the Mac, everything behaves exactly as expected. The user punches in the command and GPT 5.6 starts up normally. But on the Linux machine, total instant failure. The request just immediately crashes out. And remember, identical account, identical version of Codex.
And it doesn't just crash, it spits out a completely contradictory error message. The terminal basically says, model requires a newer version of Codex, and then immediately follows it up with 404 GPT 5.6 model not found. Think about how baffling that is for a second. The system is simultaneously telling the user, hey, you need an update, while also saying, oh, and the thing you're looking for, it simply doesn't exist.
Now, the ultimate paradox here is this. Any good dev seeing an update required prompt is going to immediately run a diagnostic. So the user runs Codex Doctor, the built-in tool. And what does the doctor say? It insists the Linux installation is completely up to date. It reports the CLI is already running the latest available version. So the software is demanding an update that the software itself says doesn't even exist. You can't make this up.
Moving on to Section 3, the process of elimination.
Faced with this kind of paradox, a seasoned developer enters a rigorous, rapid-fire process of elimination. Our user, #AGreenhandJack, didn't just throw their hands up, they got to work. They verified the OpenAI account and off-matched. Check. They did a fresh logout and login. Check. Completely reinstalled Codex, even trying it via NPM. Check. They went deep into system-level dependencies, making sure Bubblewrap was installed and working. Check the network connectivity. They literally checked every single logical box.
And the result? Nothing above changes the behavior. Man, imagine the sheer frustration of hitting that brick wall. You have done absolutely everything right. You've eliminated user error, network error, authentication error, and installation error. Locally, on that Ubuntu machine, the software is absolutely pristine. And that leads us to Section 4, one crucial clue. Every good mystery has a eureka moment. The user started digging way deeper into the verbose logs generated by that diagnostic tool. And buried way down in that text, they noticed a tiny but massively significant discrepancy between the two operating systems. And get this, it had absolutely nothing to do with the code on their machine. It was all about the rollout information being reported by Codex Doctor.
When checking the diagnostic data for the Mac, the system was essentially operating in a fully deployed environment. The macOS rollout was at a solid 100%, allowing the client to seamlessly connect with those GPT 5.6 models on the server side. Basically, the infrastructure was fully expecting and welcoming the macOS connection.
But here is the smoking gun. When they checked the exact same log on their Linux machine, the rollout wasn't complete. The Linux rollout was sitting at a mere 23.4%. Suddenly, the whole shebang clicks right into place. The local machine wasn't the problem at all. So, this all comes down to understanding what a staged rollout actually is. It's basically a safety mechanism. Instead of flipping a giant switch and giving a new feature like GPT-5.6 access to millions of users all at once, companies release it gradually, 10%, then 20%, and so on. Why does this solve our mystery? Because even though our user downloaded the correct Codex version 0.144.0 on both computers, the server-side deployment for Linux users simply hadn't reached them yet. The Linux client was looking for model metadata, returning that 404 error, purely because the cloud backend hadn't granted their specific Linux client access yet.
Finally, Section 5, Case Closed. Armed with this info, we can finally look at the resolution. Once the report was submitted, a GitHub Actions bot flagged it almost immediately. The bot and a few other community members noted this was actually a potential duplicate of another issue. Turns out, this was not an isolated incident. It was part of a much wider pattern of cloud deployment sync glitches affecting tons of users. Because the root cause was firmly identified as a server-side staged rollout, not a local software bug, a green hand Jack went ahead and closed the ticket. Mystery solved.
Which leaves us with this final, pretty provocative thought. In today's dev environment, you can literally do everything perfectly. You can have the exact right version, the perfect configs, flawless network connectivity. But when the software on your local desk perfectly matches, yet the invisible cloud deployment in some server farm halfway across the world doesn't, who is really at fault? It's a brilliant reminder of the hidden complexities of modern cross-platform software. Sometimes the code on your machine is only half the story. Thanks so much for joining me for this explainer, and hey, I hope this leaves you eager to dig a little deeper into those logs the next time you hit a wall.